My name is Livvy Science. I am 14 years old and in 9th grade, and my project is measuring sky glow with a digital camera. My question is, how does changing the shutter speed on a digital camera affect the amount of sky glow shown in a photo? My hypothesis is, if I change the shutter speed on my camera to a slower speed, then more sky glow will appear in my photo. And a couple of these words I didn't understand before I started this project. One of them was sky glow. And sky glow is the glow in the sky, sometimes referred to as light pollution, and some people actually protest against it, from building lights or street lights. It limits the number of stars in the sky that we can see. And another word is, or two words, is shutter speed. Shutter speed is the choice of how long you want your camera shutter to stay open, allowing more light to be let in the slower the speed. So a 30-second shutter speed, for example, would have a lot more light let in than 1/1000th of a second shutter speed. My materials were my digital camera. This is the camera that I used right here, and you can see my camera and my tripod in this photo when I was taking sky glow photos. A white piece of paper, my science notebook, and 2 locations, at least, in which I could take photos of the night sky. To start my procedure, I had to calibrate my digital camera, and this was just making sure that my lighting conditions were right so that my photos of the sky turned out okay. And these are my calibration photos over here. I had 16 altogether, but you can see those. This is my 30-second, and this is my 1/1000th of a second. And they were...
Pretty dramatic.
And I taped a piece of white paper on the wall next to a window in a room that had natural light, but it wasn't direct sunlight that was on the paper. And I took a series of photos with the camera settings of full manual mode, ISO of 200, which is sensitivity to light, and aperture of f2.8. And then I took different shutter speeds, 16 altogether. The shutter speeds were 30 seconds, 15 seconds, 8, 4, 2, 1, 1/2, 1/4, 1/8, 1/15, 1/30th, 1/60th, 1/125th, 1/250th, 1/500th, and 1/1000th seconds. And you can view those in my research paper. After I took the series of photos, I took another set just to make sure that my lighting conditions were the same in both sets. Next, I went on to the computer software ImageJ to calibrate my digital, to analyze my pixel value in each photo. And pixel value is just the amount of pixels in a photo. So the more pixels, the more light in a photo, or in my case, the more stars. And you can view those right here. ImageJ would give me histograms like these, but these are not the histograms for this set of photos. These are for later on, and I'll explain them. They give you histograms, and they tell you the mean, the standard deviation, the minimum, the maximum, and the mode. And those are all just related to pixel intensity in a photo. And I had to make this graph right here. This is for the first set of white paper photos, and this is for the second, and it's just the information there set into a graph. Next, I made a calibration curve to make sure that my lighting conditions were the same and that I wasn't doing anything wrong. So this right here is the calibration curve. My average pixel value goes over here, which is the mean from the histogram. And my exposure time, which is the same thing as shutter speed, goes down here. And this is a logarithmic scale, and this is a linear scale going up. And the red dots are from my set number 1 of my white paper photos, and the blue dots are from set number 2. And if the calibration curve would have been far apart, then I would have had to retake my photos. So this was making sure. They were close together, so I only had to do each set once. The next step was taking my sky glow photos. Now, the first set of sky glow photos was taken in the brighter location, and this location was in my backyard in Mount Hope, West Virginia. It was taken around 8:15 at night, somewhere from 8:15 to 8:45. It was a clear night with no clouds. This is me taking those photos in my yard. I took a series of photos with the same camera settings and every single shutter speed that I mentioned earlier. And these are those photos right here. You can view them if you'd like. You can flip through later on if you want to. It goes from the 30-second all the way down to the 1/1000th of a second. That's the brighter sky glow, so it should have more sky glow than the other set. Next, I had to calibrate my camera. Next, I had to analyze these photos on ImageJ. So I went on there, and I made graphs. I had histograms. These are also not those histograms. These come in later. And I used the histogram information. This is from this set of photos. And then I was ready to take my next set of sky glow photos. And these can be viewed right here. They are easier viewed with a flashlight because of lighting conditions inside buildings. I took this set of photos on Mill Creek Road in Mount Hope, West Virginia on a clear night around the same time as the other photos with the same camera settings and the same shutter speeds. You can shine the flashlight on these photos and see the stars that appear. It's a significant amount of more stars than the brighter photos because of less sky glow. Next, Next, I went on to ImageJ again and analyzed both sets of photos. These are the histograms for the darker set of photos. Now I come into those. So you can see this is the histogram for the 30-second photo, and I had all in between, and then this is the one from the 1/1000th of a second. So you can see the pixel intensity here is much, much higher than the pixel intensity here because that photo is just about black over there. And you can see, you can pick a star out and follow it the whole way, and you can see how it gradually disappears. Next, I had to find the EET of each photo, which is the equivalent exposure time. And so to do this, I had to take my shutter speed for a photo. I did this with each photo, and I would find it on this calibration curve. So like if I was using the 30-second exposure time photo, I would come up to 30, so 10, 20, 30. Then I would follow it across until I hit the calibration curve, which is about right here, so 0.01. I had to do this for each photo, and I wrote them down here in my lab notebook. And after doing this, I had to compare my photos. So I added the photos from the first set of sky glow photos and the shutter speeds from the and the EETs of the second set together, and the set with the smallest EET is the set with the least amount of sky glow. So it's the darker set, and it worked out because it was this set. So everything worked out in my camera settings. So after doing this, I could divide. So I had to divide my EET of my brighter photo. So I would take the 30-second EET of my brighter photo and divide it by the 30-second EET of my darker photo. And then the results were, like, if I took the 30-second photo and I had an EET of 0.008, and then on my darker photos I had an EET of 0.002, I divided those and the answer was 4. So that means the darker sky glow photos were 4 times darker than the brighter sky glow photos. My conclusion was taking sky glow photos with a slow shutter speed allows more light and stars to appear in the photo. Allows more sky glow and stars to appear in the photo. And what I learned from this project, a few things were, I learned how to work my camera a lot easier. I got my camera for my birthday in May, and I really didn't understand how to operate it, so I had to learn that for this project, and I'm so thankful. And then I also learned how significant and how big a part lit houses or buildings or streetlights play in how many stars you can see. So if you were in the city, you would see hardly any stars, but if you were out in the country, you can see stars all around you. And I also learned how to make a calibration curve and how to compare data from different sites, which was the what my project was for in general. That is all. Thank you for listening. Do you have any questions?
How long did it take you when you were out?
It didn't take long. The 30-second, I had to stand there forever and just wait, and then I had to do that a lot sometimes because that was my test. That was the first one that I took, and so that was my test. And a lot of times it turned out wrong, so I had to redo it. But it probably took about 30 minutes, and it was really cold.
as long as that.
I was gonna ask, well, I appreciate you, defining stuff, because I was gonna ask both of this. But, if you change your variable, if you went and did it, like, outside of Charleston or something, what would come out of it?
I saw where it would be interesting to do a project. You can compare sky glow in different phases of the moon. I thought that would be really fun.
And that would be,
So if I wanted to expand on my project, I could do that.
Yeah.
we were on vacation a few years ago. I asked my wife if she'd ever seen the stars in a really, really bright place, because we happened to be at night driving between two of the national parks in Utah.
Oh,
And so we stopped and pulled in on a little side road and just turned off the lights and waited a little bit and got out of the car after our eyes adjusted and all that. And man, it was
It is, we used to live,
just amazing.
we used to live out west. We lived in Nevada for a while, and the